Hi, I'm Katie, and welcome to IB Biology. I'm your new teaching assistant for this term. So today we'll be going over one of the core understandings within Unit 2.4, which states that amino acids can be linked together in any sequence, giving a huge range of possible polypeptides. So basically, why do we even have that many polypeptides? We can frame our explanation in two parts. The first one being the natural diversity of individual amino acids, and the second would be the numerous possible arrangements of these amino acids to form a polypeptide.
So, what is an amino acid? Amino acids are building blocks for proteins, or you can say proteins are composed of amino acid subunits. The generalized structure of an amino acid includes 5 basic components: an amine group, a carboxyl group, a variable side chain, a carbon atom, and a hydrogen atom. There are a total of 20 different types of amino acids that are universal to organisms. But why are there even 20 types of amino acids when there's just one generalized structure, you ask? Well, the key lies in the variable side chain, or the R group. The R group distinguishes one amino acid from another by its unique chemical properties, giving amino acids their distinctive chemistries. So some are polar, some are nonpolar, some are ionic, and some are uncharged. Think of it as how you would differentiate a person based on their physical traits. Amino acids will undergo a condensation reaction to form polypeptides, with the establishment of a peptide bond between a carboxyl group of one amino acid and the amine group of another, accompanied by the loss of a water molecule. Dipeptides will continue to bond with other amino acids until complete chains of polypeptide are formed. And the general idea is this: because there are so many types of amino acids, each of them will bond differently, and so there will also be trillions of ways in which the amino acid residues can be arranged to form a polypeptide. Here's a quick example. Suppose we want to find out how many amino acid sequences we can make if we group residues into combinations of 10. General formula for this is 20 to the power of n, where 20 is the total types of amino acids and n is the amino acid that goes into one sequence. Viewing this formula gives us 20 to the 10, which is an insanely large amount of combinations. So to tie this all up, natural polypeptides are referred to as proteins when they consist of about 50 to 2,000 amino acid residues in length. Just imagine how many possible polypeptide compositions we can have. These are the sources that I used to make this video, so if you want to learn more about the topic, it's a very good place to start. I also drew my own visual aids, but if you want to know how polypeptide chains actually look like, do search it up on the internet. Thank you for listening.